This lesson, we're going to be continuing talking about substitution as a method for solving systems, except this time this is part 2. So why is it called part 2? Well, last time, you guys, those examples are now considered like the basic, I guess we'll say easier substitution problems. These problems are going to be much more challenging than last lesson. But why are they more challenging? Well, I pointed out to you last time that to use substitution, the setup matters. And what the setup had to be is you have to have one variable somewhere within the system that's alone on one side of the equal sign. So like one of the equations has to be like y equals this or x equals this. Last time, every single system was already set up like that. Okay, so like if I look at the notes from last time, these both had y alone. This one had y alone. This one had x alone. This one had y alone. So they were already set up nicely. These examples are not going to be set up nicely, making them more challenging. So one of today's goals is to be able to find the most convenient place to get a variable alone. Okay, because realistically, I could get x or y, any x or y within the system by itself, but to save yourself the headache that fractions and decimals cause, you definitely want to find the most convenient place. And to do that, you guys, it just takes practice. Okay, I promise you that if you practice these enough, you will have it down and it'll be nothing. Okay, and this is such a crucial skill to be able to have, solving a system by substitution, because you'll do this all year in geometry, you'll do it in algebra 2, and you'll even see it a lot next semester. So like this stuff is just really necessary as a math skill. Okay, so the directions are still the same. I want to solve using substitution. I know the answer is an ordered pair. It's an x and a y. The only difference is this is not set up nicely. Because I know to do substitution, I have to have an x or a y by itself somewhere. So I'm going to take a step back and I'm going to look at this system. This x, this y, this x, this y, I can get any of those alone. On most of the problems, I don't want to say all of them because number 2 would prove me wrong, but on most of the problems, here's what you want to look for. You want to look for a variable with a positive 1 in front of it. 8 times out of 10, I'll say. That is going to be the easiest place to get a variable by itself. So that would mean I'm going to ignore the x's because I see -4 and I see -5. That is not a positive 1. But if you see the y's here, both of those just have a 1 sitting in front of them. So I'll say a lot of times, like, look for the plain x or y. All I mean by plain is like there's just a 1 or not even a number at all written in front of it. Those are the easiest variables to get alone. Since I have 2 options, I just choose one. So for no rhyme or reason, I'm just going to choose the first one. I want to get this y alone. So don't move that, move the other term, the -4x. And you would do that by adding it to both sides. So off to the right here, I'm going to write what that equation would look like. Actually below, I'll write it off to the right. I'm indecisive. I'm going to write it as y equals 4x plus 6. And notice I wrote it in mx plus b. You could have said 6 plus 4x. It doesn't matter. So that's the same line. I just chose to rewrite it. I'm going to cross off, just so I don't get confused and use that for anything. I'm going to cross off the work on that first line. And now I'm going to look at my system as these 2 equations. Now that I have a y by itself in this first equation, I'm ready to do what I learned last time. Solve this by substitution. And if you remember the examples we did last time, you focus on the equation where there is a variable by itself. So y is equal to, or y is the same thing as 4x plus 6. So I come down to the other equation. I'm going to find y, and I'm going to replace it with 4x plus 6. So when I rewrite that second equation, and I know to use parentheses, instead of putting plus y, I'm going to put plus 4x plus 6. The parentheses actually don't matter on this one because there's just a 1 there, and distributing a 1 will do absolutely nothing. So I'm safe to write the equation without it. If you substitute and now you have an equation that only has x's or y's, then you did it right, hopefully. So you can go ahead and solve this for x. So I'm going to combine the x's. They're on the same side, so I just do the problem like it looks. Negative 5x plus 4x is negative 1x. Okay, and now I'm just going to solve this. So I would subtract 6, 15, and then I divide by negative 1. So x would be negative 15. You can write your answer as an ordered pair, or you can just like say this is x, this is y. I don't care. Okay, but we know we're not done. You kind of have to find two answers, it feels like, when you do substitution. Even though your answer is technically just one answer, one ordered pair, it kind of feels like two different answers here. Okay, so come back up to the top, and you pick one of your equations to plug it into. I mentioned last time that if you pick the equation that has the variable alone, that's the easiest place to solve for your other variable. So I'm going to look here where y is alone. I know that x is negative 15. So I'm going to plug that in right there for x, and then I'm just going to turn to my calculator to figure out what y equals. Ew, gross answer. Y is negative 54. Okay, so we saw a lot of examples last time that proved why graphing sucks. I don't know about you, but I do not want to graph two lines that cross at this ordered pair. Your graph would have to be humongous to be able to see that answer. You'd be plotting points all day long. So we need substitution because graphing is terrible. All right, so there's the first example. And I know, I totally get it. It's a lot of work. But like I said, this is such a necessary math skill. And realistically, you guys, the only thing that was different about this example as opposed to the ones we learned yesterday was this very first step. The second I had it rewritten as y equals 4x plus 6, all this work I taught you last time. Okay, so let's look at number 2. This is not set up for substitution. There is not an x or a y by itself. I need to find the most convenient place. In this example, the x's and the y's all have a number that's not positive 1 in front of it. So I got to shift gears. I'm hopeful that it would jump out at you that the second equation, if I look at the left-hand side, it's 2y. So it jumps out to me that if I just move that 2, I'm going to have y by itself. So you really want to look for a place where you only have to do one thing to get a variable alone. So that one thing here is just dividing by 2. And then I've got the equation y equals negative 2x minus 4. I like to cross off the equation that I changed because now I'm going to be looking at these two as my system. And you guys, this is like the exact same thing we did yesterday now. That first step is the only thing different with part 2 here. So y is the same thing as negative 2x minus 4. So I come to the first equation and I find y, let me stick with purple, and I'm going to plug in negative 2x minus 4 in y's place. So rewrite your top equation. Instead of putting y next to the 5, put this negative 2x minus 4. Now I'm just using an x so I can solve this. Okay, so I distribute. And let's see here. Okay, so combine the x's. 10 minus 10, what do you know? That's 0. I like problems like this. This isn't very much work now. When the x's cancel out, we learned this last time, it's a special case. So there isn't a solution that's an ordered pair. It's either no solution or infinite. So remember, we look at what's left. And this is not true. Negative 20 does not equal 2, so this is a false statement. That means that there are no solutions. And if you think to yourself, okay, well, what kinds of lines are these? Well, if there's no solution, that means they never cross. So these are parallel lines. So no solutions is the answer, but it's good to know, like, oh yeah, okay, these lines wouldn't cross, they'd be parallel. Okay, so that wasn't a ton of work. That's nice. Let's look at the back and do just a few examples here. So I'm going to do this one for you. I am going to have you try one of the others on your own though, but let's go ahead and start with number 3. And I would notice right away that graphing would also suck for this problem, I'm not going to lie, because if you've got decimals involved right away, I don't want to graph something like that. I want to use substitution. I need an x or a y alone. Okay, so here's where this tip comes in. Look for an x or a y that has a positive 1 in front. Not that one, not that one, not that one. Right there, this plain x in the first equation is what I want to get by itself. So I'm going to move the 1.2y over by adding it. So this equation is going to look like x equals -3 plus 1.2y. I'm going to cross off the first equation so I don't use it for anything. These two equations now make up my system. Okay, so x is the same thing as -3 plus 1.2y. So I'm going to come here and I'm going to replace or substitute x with this expression. So let's rewrite this second equation. Don't forget your parentheses. Now I have an equation that just has y's, so I can solve this for y. It's real easy to make a small mistake when you've got all these decimals involved, so just be real careful. We want to say minus 4.8. Okay, now I'm going to combine the y's. So they're on the same side, so I just add them. And I would get 2.12. Gross. Okay, now this is just a two-step equation, so I'm going to add 4.8. And I get 16.8. And then I divide by 2.12. And I don't think this is going to come out nicely. Oh, sick. Okay, this is not the best example because, well, I guess it could be an example. I can't get a perfect answer here because this decimal is going to go on forever. So if I round it, I'm not being exact. If you got an example like this, hopefully the directions would tell you what to round it to. This one didn't, so I'm kind of like doing whatever I want now, so I'm just going to say about 7.9. And this is the about sign. Kind of like little squigglies. Gross answer. Again, something I definitely would not want to graph. Okay, it's kind of like two answers when you do substitution. You have to find the y and you have to find the x. So bring it back up, go to where the variable was alone, plug in your y right here to get the x value. Ooh, I'm running out of room. 7.9. Sorry, that says 1.2 times 7.9. So I'm just going to plug that into my calculator. That's what I wrote right there. Sorry if you can't read it. And I get x is about, again, it's not exact because I rounded the 7.8, 6.48. Ugh, sick system right there, but hey. Proves why graphing's not good. Okay, I'm going to do what I did last lesson, and I'm going to set up the word problem, but I'm not going to solve it just because I don't want to use the time and make this video even longer. So again though, I mentioned last time, you guys, if it's a systems test and you get a word problem, you best be writing two equations. I know that before I even start, so let's read it. A farmer grows acres of sunflowers and flax on his 240-acre farm. This year, he wants to plant 80 more acres of sunflowers than of flax. How many acres of each crop does the farmer need to plant? Okay, there's two equations, there's two variables. So in this situation, the two variables I'm talking about are the crops. So I'm going to use S for sunflowers and F for flax. Okay, the first equation, and I will tell you next week we're going to do a whole day where we just practice word problems. So me just doing a problem here and there is just kind of a build up to that. Okay, but we will practice a ton. So don't like stress about not getting the word problems right off the bat. So the way that you set this one up, and there's only two numbers, which is kind of weird looking, but the first sentence I can write an equation from. He wants to grow sunflowers and flax, and he's got 240 acres to do it on. So basically, the sunflowers plus the flax, I want that to total 240 acres. And I guess it should say like acres of sunflowers, acres of flax, if we're being real specific here. So between the two crops, I want to cover 240 acres. So I used that number once, that one's out. The second sentence you can use to write the second equation, and this is where it's going to be just a little tricky. He wants to plant 80 more acres of sunflowers. Okay, so there needs to be more sunflowers than flax. So here's what I'm going to do. To get the sunflowers are 80 more than the flax. So on the other side, I need to take the flax and I need to add 80 to it, and that number of acres will equal how many sunflowers I have. That equation can be kind of tricky, but now I can see that it'd be set up for substitution. So I could take this and I could substitute it for S and I could solve it from there. Again, I'm not going to waste your time doing that right now. I want you guys to just do number 5. Do your best. We'll practice it tomorrow. Show me what you would get.